All right, calculus, welcome to your notes video for this TGIM 22624. I'm sorry to not be with you. I'm going to kind of make this a little quick again, you guys. It says to do, well, just all these questions here. I think we're doing all these questions. It doesn't say do all the circle questions like stats does. Anyway, shouldn't I do these? This is going to be kind of quick. This video is being made at 1:11 p.m. here on a glorious Sunday. Okay, the outdoors are calling to me again. So I'll make this quick. I know all of you are outside at the moment as well, not inside watching other people play video games, right? Excellent. Okay, folks, so here it is. This is from SIUE. This is the sample final for them. So consider the function f of x is equal to x times e to the negative x. Okay, and it wants to know intervals of increase and decrease. So, this is just good practice for the exam that you guys are going to take on Thursday and Friday. Just good practice overall. If I want to find intervals of increase, decrease, it's a critical number time. I'll take a derivative, set it equal to 0. Derivative of the first times second plus the first times derivative of the second. So that is the derivative. You can pause it. You can help each other out. There's one of these I want you to check because I don't like the answer that we get, but I did it 2 different times. So this, always factor out either negative x. This can't be 0. So I'm left with 1 minus x equals 1. That gives me 2 intervals here, negative infinity to 1, 1 to infinity. Test number, how about of 0 and 2? I think f prime of x is positive than negative. So that's what I got. Again, pause this when you need to. Do some of these on your own. So folks, this only has a max, okay? So it goes from increasing then to decreasing. So just one transition point here of 1, it only has a max. There is no min. Okay, so there is a max at 1, plug 1 in for x. All right, 1 e to the negative first, which is 1 over e. There's no minimum here. That can happen. And then when is it concave up, concave down? Whoa, second derivative time. So if you guys can handle this one, I think all the polynomials are going to be easy peasy. Here's the derivative, the first derivative. So I'm going to take the derivative of this first part, which is there. Then I'm going to say minus. So I'm just going to put the minus on the outside. I'm going to use the product rule there. Derivative of the first times second plus first times derivative of the second. One should look familiar. Carry then, so a negative times negative. What happened there? I don't like that. A boo-boo has been made. All right, a boo-boo has been made. All right, so first off, this is okay, but you will be, this is a negative, but you're subtracting it, okay? So you see this? So a negative times a negative means this is a positive, all right? Which means this is going to be a positive, which means now set this equal to 0. Okay, which means set this equal to 0, which means x is 2. X is 2 is your critical number. So 2, 2. Very, very easy. Very, very easy boo-boo to make. So I'm going to use 0 here and 3 there. All right, so when I plug 0 in for x, I'll get a negative. So easy. And when I put 3 in for x here, I'll get a positive. Okay, so it's concave up on 2 to infinity. Concave down on negative infinity to 2. Yes, yes, yes. All right, great question for us. Next one here, we've actually done using the definition of derivative. Oh no, find f prime of 2. Okay, so we've done this using definition of derivative. So this is it. That's the definition of derivative. All right. So what is f of x plus h? That's where x plus h goes. So take a look at the denominators then. They both have 3's. This one has an x, so give it x over x. This one needs the x plus h over x plus h. That's what we're doing. 1 times x and h just gives us x and h. Now we will subtract. When we subtract, that negative h is going to remain. Now I can let, well, first off, then the h's will cancel. Now I can let h go to 0. I got ahead of myself here. So that is, that's f prime of x. Awesome. So f prime of 2. So we have done this in probably an SIU final. Just plug 2 in for x. Plug 2 in for x. Again, pause this whenever you need it. You either want to know this stuff for your exam later this week or for your final, your 3-day final. All right, like number 4 here, this is a great one, okay? It's going to be continuous when x squared minus 1 equals 2cx. They are equal when x is 3. Set them equal to each other, plug 3 in for x. See if you can finish that one, easy peasy. I will give you a set answer. All right. Find f prime of x. You should simplify. Shout out to the E. All right. SIU Carbondale's like, you guys don't need to simplify. Wimpy. All right. You should simplify. Okay. Simple product rule here. Derivative of first times second plus first times derivative of second. Okay. 1 over 3x times 3. So think about what the antiderivative of 1 over x is. Hint, hint, wink, wink. These 3's cancel. X squared over x is simply x. And the 3's right there. Not bad. Good old-fashioned quotient rule. Low, d high, minus. Why in the world did I put plus? Minus. Goodness, seriously. Minus high, d low. All right. The order doesn't really matter. All over the square of what's below. Definitely a minus. Don't rush through answers, folks. All over the square of what's below. You don't have any sine squared plus cosine squared situation, so I would leave it as such. All right. That would be good on the simplifying, I would think. Here we go, folks. Here we go. You might have seen this one exactly on, shoot, I mean, you might see it on your exam. You've maybe seen it on a quiz. This one is definitely going to be seeing something like it this week. They are a big fan of the sphere. Air is being pumped. Air is being pumped into, so they have told you dV/dt, it is 7 and a positive 7. They want you to find dr/dt when the radius is, well, how do we know it's 3? Okay, well, first off, the volume is 36 pi. They gave you the formula. 36 pi is 4/3 pi r cubed. Bye pi. You're going to multiply both sides by 3/4. 3/4 of 36 is 27. Now, mind you, it's from SIUE. They don't allow a calculator in class, okay? 27, cubed root of 27. You should know how to do that. That's 3. So, we're going to take the derivative of this. Plug 3 in for dV/dt is 4/3 pi. The derivative of r to the third would be 3r squared dr/dt. The 3's cancel. Plug 3, what did I say, the pi? 3's cancel. Yeah, these 2 3's cancel. We got more 3's coming up here. All right, so that is 9. 9 times 4 is 36 pi. 7 divided by 36 pi is dr/dt, and we're talking about centimeters per second. Again, to have this work, know how to do this work. You are turning this into my top tray before you go, but if you got to pause it, because I'm going too quick, I still got another video to make. Just pause it. All right, so here's where I definitely want you to check my work, because I got an answer that I don't like, but I did it a few times. Find the equation of the tangent line to this curve at the point pi 0. Okay, so I rewrote this. Now, in order to find the equation of the tangent line, I need to take the derivative. Okay, this is implicit differentiation. These y's, I can't say y equals blank in terms of x. So they're not going anywhere. So I have the product rule there and here. Derivative of the first. So now it's e to the y times y prime times the second plus derivative of the first. Or I'm sorry, plus the first times derivative of the second plus, what's the derivative of x? Simply 1 going to have minus. Okay? I'm now putting like this in parentheses. So minus, I'm putting xy in parentheses. Derivative of the first times the second plus the first times derivative of the second equals, what's the derivative of pi? 0. Bring the negative sign through, right? And now we have this. Now I put y prime out front. These are my two y primes. I'm going to keep them on the left now. And then another way I did this, I moved them over to the right. It did not matter. I still got the same answer I don't love. So I'm going to keep these on the left. I'm going to move this over. It's now positive. I'm going to move this over. It's now negative. I'm going to move this over. It's now negative. I'm going to factor out the y prime. I'm going to divide by both sides by this. Okay, that on itself, you know, I mean, it doesn't look great, but you wouldn't be upset about that sort of thing. So we're going to plug 0 in for y and pi in for x. 0 in for y and pi in for x. So you're going to have 0 minus e to the 0 cosine pi minus 1 all over e to the 0 sine pi minus pi. Okay, so that is 0. E to the 0 is 1. Cosine of pi is a negative 1 times a negative 1. It's going to give you 1 up here. And then you're subtracting 1. Then you have 0 because sine pi is 0 minus pi. You get 0 over, well, negative pi, but it doesn't matter. You get a slope of 0, which is silly. I don't think they should have done that. Anyway, you guys try it. Try it again. I tried it twice. I kept getting slope of 0, which is not good for them to put on a final because someone could like guess it. 0. All right. Show that the equation 3x plus 2 cosine x plus 5 is exactly 1 real root. We had one of these questions to start our chapter. So take the derivative, folks. Take the derivative. 3 minus 2 sine x. Set the derivative equal to 0. And if you do that, if you try sine inverse 3 over 2, it's gonna say domain error, right? Because sine x, where in the unit circle do you have a sine ratio of 3 over 2? Never. So sine inverse 3 over 2 is undefined. That can't happen. So the derivative can never be 0. So if the derivative can never be 0, there's no turning point. So it's either only going up or only going down. If the derivative is never 0, it can only cross the x-axis once. And if we were to graph this, we would see that f of x is always positive. All right, the derivative is never 0. So if the derivative is never 0, the function is either always increasing or decreasing. It can only cross the x-axis one time. Also, like, and here's how we also know that derivative is never below 1, so that derivative is always positive. So f prime of x, always positive. That means it's always increasing. All right. Cool, folks. That was it. That was kind of quick. Use the rest of the time, if you have any time after pausing this, to study more for the exam. We'll talk about a few other questions that are in your packet, and then I'll give you a few other to think about in exam Thursday and Friday. Turn this in before we go. This is Yak Math Videos, signing out.